Hi, thank you for coming to my talk. My name is Talya, and I joined Klarna about a year ago. I work at the Tel Aviv site as a software engineer for the on-demand team. And today I'm going to talk with you very briefly about sentiment analysis. How come, you ask? Well, a few years ago, I took an online course at this really awesome site called KonferenSE, where you can get real-life professors giving out real-life courses in just about any topic you can think of. I chose natural language processing. And I really enjoyed it because it sort of demystified some of the seemingly magic services that all of us use every day. And it showed me that I can do these things as well in my home. And in this talk today, my hopes are to show you both that it's interesting and that you can also do the same. So let's get started. First thing, what is this natural processing language I was talking about? Natural language processing, or NLP for short, is the field of computer science, which is basically about how computers process human written language, as opposed to, say, programming language. And we can see applications of natural language processing all around us. The more common, even trivial one, you can say, is spelling correction and grammar correction. Also, the ability of Google, for example, to interpret questions that you ask in free form and answer them in this nice one-box way. We call that question answering. That's another field of natural language processing. Your spam inbox also uses natural language processing. Spam detection is a form of natural language processing, which is a text classification. That means you take a piece of text and you say whether it belongs to a class or not. In this case, in spam case, the class is obviously spam. Is this piece of text spam or is it not? And to the star of our talk, sentiment analysis, that's also a type of natural language processing of NLP. And that, like spam, is also a type of text classification, where we take pieces of text and we say whether they belong to a class or not, the class being positive or negative, two classes. And we have many applications of sentiment analysis. We can do a lot of interesting things with sentiment analysis. A lot of them have to do with Twitter. Twitter is basically a huge database of pieces of text. And in this example that I'm showing you, we have the tweets that are talking about a recent event that we had that was in the United States not so long ago, where a big retail company called Target decided to remove the gender signs, boys and girls, from its toy aisles. Some people were against it and some people were pro it, as you can see here. And what Target could have done and might have done is take all the tweets that related to this marketing decision, to this decision that they took, and see if they had more sentiment, analyze them, and see if they had more positive responses or more negative responses, and maybe understand if this decision was positive in the opinion of the user or negative in the opinion of the user. And other retail companies could use this as a case study and decide whether they want to do the same decision or not. The question that we ask in this specific example is taking a tweet and asking, is it positive or is it negative? We can ask more complicated questions than that. For example, this is a website that is called Applause, where you can type in a name of a mobile app, and then it gives you a set of aspects that every mobile app has. Elegance, usability, also privacy, the list goes on here. I'm only showing you half of what Applause shows. And it tells you where the mobile app that you typed in ranks in each and every one of these aspects. And it does that by analyzing the sentiment in the user reviews of this mobile app. And that is very interesting for a company to know what are the strengths and the weaknesses of its mobile app, judging by whom matters the most, which are the users. If we think about it, the question that is asked here, what Applause is doing here is taking a piece of text, a review in this context, and asking it, what is positive in this review? What is negative in this review? So we were talking about different questions you can ask in the context of sentiment analysis. A question which is more polar, a binary question. Here's a text, is it positive, is it negative? We can also accept the fact that we won't always be very 100% sure of whether this text is positive or negative. We can accept an answer which is, I'm 75% confident that this text is positive and 46% confident that this text is negative. That's also an option. And we can ask the question of what is the target of the sentiment in our piece of text? What is the writer so happy about anyway? And so, that's a spoiler. What we're going to do now is ask the question of polarity. We want to focus on, if we get back to the previous slide, I'm going to focus on the question of polarity alone in this talk, but keep in mind that the questions of confidence and target are not very much different from it. And it's going to include some math, very little math, not complicated math, but still let me apologize using that cat that we've seen before. And now we can get down to the subject of matter. So, let's define our problem. So we have a piece of text. It could be a tweet, it could be a review, and we have two classes, the class of positivity and the class of negativity. And what we want to ask is the binary question, is this text positive or is it negative? I'm going to call this question the text sentimentality question. It's not a professional name, it's just something that I made up, so it will be easier to relate to in later slides. And the way we are going to solve it is by computing the probability of the positive class, given our piece of text, and the probability of the negative class, given our piece of text. Just think which one is more probable, and pick this one. That's it. That's the entire thing. I hope that you all are familiar with the concept of conditional probability. This is what we see here. The probability of something given that something exists, and if not, I hope you will get it later on in this presentation. I got you covered. So what we are about to do is actually computing two things: the probability of a class given our specific piece of text when the class is one time the positive class and the other time the negative class. The implementation of this text sentimentality problem that we're about to see is called naive Bayes. There are many other types of implementation, but this is a more easier one and it's very useful. So we'll stick to this. Okay, the first thing that we are going to do is a little probability trick, Bayes probability trick, if that rings a bell to anyone, that basically says, if I'm having a hard time computing a conditional probability, let's just use another formula that uses the reverse conditional probability instead. And that's very useful for times where your original conditional probability is hard, but the reverse one is easier. And I'm already starting to see your faces going all dazed and confused, so I want to stop at this point and talk about something a little more pleasant. Let's talk about the weather. I want to give an example from another domain, so it will maybe be easier to understand the example for our domain, the domain of sentiment analysis. So say this is a year. And it's a simplified year for sake of the example, so it only has 2 seasons, winter and summer. And they take the exact same time, 6 months each. And we're in Sweden, so in our simplified year, we have rain each and every day of winter, and we have rain exactly half of the days of summer. And now, and this is also a simplified room for the sake of the example, so it has a window right here, and we are looking outside of the window, and it's raining. And the question that I want to ask you is, what are the odds of it being winter right now? If we formalize my question, it looks like this. Given that it's raining, what is the probability of it being winter? And that's not a completely trivial question to answer, given all the data. So we are going to do this probability trick from before, and instead solve this formula right here. Let's go over its parts one by one. The first one is the reverse conditional probability. Given that it's now winter, what are the odds of it raining? And if you look at the visualization, that's a pretty simple answer. If it's winter, it's raining all the time. The probability is 1. The second part is the probability of it being winter. What is the ratio of winter within the year? And that's also a simple question. We only have 2 seasons, they are identical in length, so the probability of winter is exactly half. And the last part is the probability of rain within the year. And if you look at the visualization, you can see that out of 4 parts of the year, 3 of them are rain, so it's going to be 3/4. Let's put all these numbers in the formula and calculate them a bit, and we are going to get 2/3. The answer to the question, given that it's raining, what is the probability of winter, is 2/3. Now, some of you may have looked at the visualization of the year and could already answer that. Because you can say that out of 3 parts of rain, 2 belong to winter. So the probability of winter given rain is 2/3. And if you can see that, then you may have already gotten the intuition of why this probability trick works, and that's great. So now let's get back to our original domain, the domain of sentiment analysis. This is our probability trick applied on our question of text sentimentality. And let's go over the parts of it one by one. So, the first part, the yellow part, is the given our sentiment class, what is the probability of finding the specific piece of text there? Like, if we look at all the positive tweets, what is the probability of seeing our exact tweet there? And think about how it's not exactly the same question as our original question of text sentimentality. Because what if our tweet is very, very, very common? What if everyone writes hello world when they first enter Twitter? Then the probability of finding our text in this sentiment, in the positive tweet class, is going to be higher, but not because it's more positive, but just because it's more common. And what if everyone bitches on Twitter and you have very few positive tweets? Then the probability of finding our piece of text there is going to be lower, but not because it's less positive, but just because the class itself is less likely. And we have to take these things into consideration. And if you notice, that's exactly what this formula does. That is exactly the probability trick. So we were talking about the yellow part. Let's call this part the text likelihood within the sentiment class, or for short, the text likelihood. Let's move on to the green part. The green part just says what is the probability of our sentiment class in the entire domain of texts. That's just like saying what is the ratio of positive tweets out of all tweets. And we can call it the sentiment class ratio, or for short, the sentiment ratio. The professional mathematical name for it will be the prior, but I'm going to stick with this because it feels more intuitive for me. And the bottom part is the probability of the text itself within all the domain of text. Like saying, what is the probability of me finding my exact tweet within all the tweets? And the fun part is that I can just get rid of it. Why can I do that? because if you think about it, we are doing two calculations. We are calculating the text sentimentality for the positive class. We're calculating text positivity, and we're calculating text negativity, and then we compare them and take the more probable, take the maximum one. Remember that? But the probability of our text within all the text has nothing to do with positivity, and it has nothing to do with negativity. It's going to come out the same value when I do the two calculations. So I can just neglect this part altogether. And that's fun because it will make our formula easier. And that is still not simplified enough for me, so I want to take another step. Let's look at our text. Our text is made of words. First word, second word, and so on. And now, instead of calculating the text likelihood within the sentiment class, I don't want to do that. I want to do another thing. I want to calculate the probability of each of its words within the sentiment class. Note that it's not the same thing. The text likelihood and the words likelihood that we've just defined are not the same thing. We neglect a lot of things here, like the order of the words or how the words relate to one another. We're basically treating our piece of text like a bag of words. And that is okay, we can do it, because turns out it still makes a sentiment classifier which is useful for many cases. So we're going to stick with it. And let's sum up everything that we just do. That we have just done. We are going to solve two problems. This equation for the class of positive, calculating the words likelihood of our piece of text in the positive class, multiplied by the ratio of the positive class, and then we are going to do it again for the negative class, the likelihood of the words for the negative class times the ratio of the negative class, take the maximum one, and there we have it. We have an answer for our question. And this is a great time to start solving it. Stop speaking in probability terms and actually have numbers there. And the way we are going to do it is by using a learning machine. Our algorithm is going to be a learning algorithm. A few words about what is a learning machine or a learning algorithm. This is an algorithm that has two phases. The first phase is the phase that every algorithm has. Input in, output out. In our case, piece of text in, positive or negative, out. The first phase is the training phase. This is where we give our learning algorithm a big chunk of training data. That means that we give it a lot of input, but the input is already tagged with the correct output. In our domain, it means that we give it a lot of pieces of text, a lot of tweets, and we already say to it, this one is negative, this one is positive, this one is positive, and so on. And then what the learning algorithm is going to do is it's going to build a partial model of the world, of the domain. And according to this partial model of the world, the learning algorithm is then in the second phase going to try and predict what is the correct output for the input that it gets. What does it mean in our domain? It means that our algorithm is going to take all these already tagged pieces of text, and it's going to build two bags of words. All the words that appear in positive texts, and all the words that appear in negative texts. If a word appears more than one time, if it appears in 600 positive texts, it's going to appear 600 times in the bag of positive words. And if a word appears both in negative texts and in positive texts, it's going to appear both in the bag of positive words and both in the bag of negative words. And that is okay. Some issues that we can think about at this point. What does it mean? A word? Is dog and dogs the same thing? Is have not and haven't the same thing? Other things that we might think about, what about words that really have nothing to do with the sentimentality and are just junk in my bags of words? To, the. These are very interesting issues. They're called stemming and stop words, and we are not going to talk about them at all today. But keep in mind that these are things that we have to relate to when building our model of the world. So now our algorithm has the model of what is the positive sentiment class. It's the bag of words from positive text. And it has a model of what is the negative class. And we can get to the issue of actually solving our problem of text sentimentality. So this is the same formula again, just a reminder of what we're about to do, calculating words likelihood and calculating sentiment ratio. Let's start with solving the sentiment ratio. So for computing the sentiment ratio, all we have to do is ask how many words we have in our sentiment class, how many words we have in the positive bag of words, compared to how many words we have in general. This would be the ratio of the positive class within our entire domain. And if you think about it, that is sort of the intuitive way we would have done it anyway. This is how we would think about the ratio of a sentiment class in our head. To solve the words likelihood, to answer the question of what is the probability of a given word from our given text given the sentiment class, what we're going to do is count how many times it appears in the sentiment class compared to how many words there are in general in that sentiment class. And that again is the intuitive way we would have answered this question anyway. What is the likelihood of a word in a bag of words? How many times it appears in relation to the size of this bag? And that's it. There we have it. It's not a very complicated formula. You can do this right now at home. And you have this algorithm for sentiment classifying. You may ask, but wait, you didn't talk about building the model almost at all. You only said a few words about it. And that's okay, because people have already done this work for you. And you can find these models of positive class and models of negative class online. So you can just go ahead and use them and implement it right there. So I want to congratulate you for reaching this part of this talk, because this is the last slide where we will actually have math. And from now on, we are going to talk about concepts. Because there are many, many other things that we didn't talk about when implementing this basic algorithm. Like, for example, look at this formula. What if we have a word that doesn't appear in any of the training input data? It's just going to zero out some of the predicates that we're going to multiply with, and we're going to get 0. And it's going to ruin our entire calculation. And that's a shame, because what if we have a sentence that is very easily classifiable, only it has a word that you can't classify because you don't know it? I see that some of you can't see the text, so this sentence says, "The movie was so funny, I nearly peed my pantaloons." What are you going to do with such a thing? Well, there are ways to solve this as well. You can look it up if you want to. It's called smoothing or Laplace smoothing. There are other issues that you can think about. For example, what if your input text has positive words like good or enjoy? This sentence, the example sentence says, "The game is not good, I didn't enjoy it at all." And when you build your model of the world, you're going to get in the negative sentiment class words like good and enjoy. And that feels wrong. And there are ways to handle this as well. Other aspects you can think of. We were only talking about words until now. But there are some punctuation marks that are very important when you come to analyze the sentiment of a sentence. And these are, of course, the emoticons, the smileys, the frownies. We might want to take that into account. The sentence here says, for those of you who can't see, now that's a Pokemon Pocket Protector, if I've ever seen one. Smiley, huge smiley. And a very interesting problem in the domain of sentiment analysis are sentences that sound positive but are actually negative, or sentences that sound negative but are actually positive. And I'm, of course, talking about sarcasm. This sentence right here says, for those of you who can't see, "Target removed gender signs on toys, and I've been wandering the aisle for days, scared and confused. ate Play-Doh to survive. So we've seen how to implement the naive Bayes algorithm for sentiment classification, and we talked about some of the ways, the aspects that you should think about when coming to implement one. And I hope that by now you are all very excited and can't wait to build a sentiment classifier on your own at home. So thank you, you've been a great audience. And if you have any questions, I would love to answer them.